Let's return to This Week in America. Here's your host, Rick Bratton.
Welcome back, everybody. Coast to Coast, This Week in America. This theory is the definitive explanation of gravity and dark matter. For scientists and novices who finally wish to unlock their secret phenomenon, simply read this book. Every mechanical and scientific example presented can be viewed in the natural world for anyone to draw their own conclusions. And whoever reads this book, well, they'll see it for themselves. Simply written and explained, straightforward, and physically represented in the natural world. If you only read one book on gravity and dark matter, it must be this book. This book is Gravitational Fields and Dark Matter, explained by Martin Walsh, our guest on This Week in America, coming to us from Australia via Skype. Martin, welcome to the program, sir. It's great to have you with us today.
Thank you, Rick. It is absolutely wonderful to be on this interview with you. It is a wonderful thing to finally have the whole book and the quantum explanation to the book finally out there in the scientific community.
And it's getting great reviews, and we want to talk about the book in detail on the program tonight. We'll give you information where the book's available and how you can get information. And of course, you can always go to our website, thisweekinamerica.us, to link on to Martin and his work. Let's start with, whose work have you followed to focus your book on?
So, as it turns out, I have only ever looked at the old pillars of science, the original pillars and the work that they have done. And I do have a lot of names which comes to mind, which is firstly Sir Isaac Newton. And of course, the experiment that I will show you will be with Newton's cradle. So we do have Sir Isaac Newton. The next people that I did focus the book on was Gottfried Wilhelm Leibniz, which of course brought us the conservation of energy law. And that is very, very important that we make sure that we follow the lines of that. The next person that I focused on was René Descartes. And I'll give you two quotes from Descartes now. And these were instrumental in my viewing of the process. So with Descartes, the first thing was never to accept for true which I did not clearly know to be as such. That is to say, carefully to avoid precipitancy and prejudice, and to comprise nothing more in my own judgment that was presented to my mind so clearly and distinctly as to exclude all grounds of doubt. Now that was a big statement for me to hear. And of course, followed on straight from that, all truths were linked with one another, so that finding a fundamental truth and proceeding with logic would open the way to all science, which indeed it has. So from there, I did read a fair few of Plato's and Socrates' early dialogues. So what this did was gave me a very good base on which my mentality on the subject would proceed. So from there, of course, Nicholas Copernicus, he was another wonderful one to read on with planetary motions. And I've got to say, Rick, reading on all of these old philosophers, to think that these people came up with these things 300 years ago is absolutely amazing.
Yes.
There's Johann Bernoulli, and with Leibniz, they both described kinetic energy as the living force. And that is very, very important. So from those, we will move on to Galileo. So Galileo was a big important factor for me. And another thing was one of his experiments, the thought experiment of 1632, had a lot of the same mechanics of Albert Einstein's man on a train. So of course, with Einstein using Galileo's work, I will piggyback straight off Einstein and use his experiment the same way he used Galileo's. So of course, the other thing was, for a point of view, to make sure that everything was correct, Rick, I did look at tidal forces, the Roche limit, the Galilean transformation, and lots of other points of view from other scientists.
You're listening to This Week in America. I'm sorry, but Martin Walsh is our guest on the program. The book is available at Amazon. The book is Gravitational Fields and Dark Matter Explained. Didn't mean to cut you off. I just wanted to jump in there and let people know, if they're following the conversation, what book we're talking about, where the book is available. And now, Martin, back to you, because this is a fascinating conversation.
So before that, I came across the current model of particle physics, and seeing the things that I did, I have written out a manifold of space and time which does adhere to the standard model of particle physics, and of course it does flow on from the work that I have done in the book.
Coming to us from Australia, Martin Walsh, our guest on the program. The book Gravitational Fields and Dark Matter Explained. Due to the subject matter of the book, how long did it take you to put the book content together? How long has the whole project taken? How did you put the book together, and how long has it taken? Because this is, all the reviews say you do it very straightforward, you break it down, it's easy to follow and be understandable. How difficult was it to make that presentation so everyone could follow this?
So, of course, to quote Einstein, and I'm not putting myself in the same room as Einstein, just simply following his quotes. And Einstein did say, if you can't explain it simply enough, you don't understand it well enough. So on that, at the start of 2000, I did start work as a scaffolder, and I have been scaffolding for 17 years, which actually put me dead center in the field of operation of gravity. So up until 2015, I had simply taken notes, observations, and then just tried to explain the things that I had naturally seen. So when it comes to that, Rick, make no mistake, and as you're probably aware, observing something is very different than being able to put into words exactly what you have seen. So it wasn't until 2016 that I realized I had enough things together and I should start putting the book in its correct place. So coming from that point, I honestly had very little idea what I was going to do, Rick. And then when I thought to myself, what do you want to say? Then all of the chapters of the book just naturally fell into progression, and the whole thing was just laid out in front of me.
And that's such an important key, that progression, because as you follow, it makes sense. You are leading us on this journey, and it makes sense. Sometimes we try to follow books like yours, and they're very difficult to follow, and you sort of you think you may have skipped a couple of chapters because it just isn't coherent and tying together. Yours is, so a remarkable job of tying this together so it does flow. The flow is very, very accurate. The book differs from Albert Einstein's warping of space-time theory. How can you accurately do this?
So how this came about was I have only recently, in the last 10 days, come across the current model of particle physics. So on seeing this model, I realized that what I was literally seeing was literally true, and instantly that did come against what Albert Einstein said about the warping of space and time. So my proof will lie in the correct model of particle physics, and of course we will run through an example of classical gravity, which is Newton's cradle. Then I will explain it with quantum gravity as to how the action happens, and then of course we will come back out to classical gravity.
You're listening to This Week in America. Our guest on the program from Australia is Martin Walsh. He's the author of Gravitational Fields and Dark Matter Explained. we're doing it. If you're listening to the radio version, please go to our website, thisweekinamerica.us, click on the videos tab, and you can watch the YouTube video, or just go to YouTube, put in This Week in America, and you will see us there with Martin and the explanation. Let me ask you this, and I think this leads into some of the demonstrations you're talking about. Where does your proof come from?
Okay, so to make sure that I do spell out all of these steps correctly, I will read a little bit of a piece that I have written, if that's okay.
Please do. Please do.
So, according to string theory, the four fundamental forces, which are electromagnetic, gravitational, and weak and strong nuclear forces. And of course, the only tie that we did not have was gravity, which the current model of particle physics says it is a gravitron, but we will change that with reality. So a quantum mechanical description of gravity is necessary on the grounds that one cannot consistently couple a classical system to a quantum one. Difficulties arise when applying the visual prescription of quantum field theory to the force of gravity. So we will do this, Rick, with bosons. So of course this subject is going to be out of the realm of some people, but there will be a lot of theoretical physicists and quantum physicists that will understand exactly what I am saying. And of course, we can look at the current model of particle physics anytime and look at what I've said and prove it to yourself. So, of course, we will start with elementary particles, which, of course, is the first part of any structure and objects in the universe. So, from our elementary particles, the ones that carry the four fundamental forces are bosons. So, and at this present time, the gravity is called gravitron bosons. So we will look at the bosons. Higgs bosons has brought, so the Higgs boson element has brought me to the current model of particle physics. So in quantum mechanics, a boson is a particle that follows the Bose-Einstein statistic. Bosons make up one of the two classes of particles, the other being fermions. Bosons include fundamental particles such as photons, gluons, W and Z bosons. The four force-carrying bosons are the gauge bosons of the standard model. So, with that, I will move straight to an important characteristic of bosons is they carry the four fundamental forces or interactions. So as I have explained, in physics, the four fundamental actions known as electromagnetic, gravity, strong and weak nuclear forces. So with this, the four fundamental forces, their interactions do not appear to be reducible to more basic interactions. So with this, these forces produce a minuscule subatomic action at distances as well and govern nuclear interactions. So being that, again, so sorry, Rick, being that I have come across the current model of particle physics in the last week, as people will come to understand, that has been an extremely overwhelming step. But nevertheless, through seeing it, I have put together the last parts of the gravitational puzzle. So we'll go back to the bosons again. The standard model lets us see elementary particles throughout their existence to great extent. I will follow the elementary particle path through the pylon path. Elementary particles that experience pylon move to bosons, which are the fundamental force carriers. Once out of the gauge boson, we have electromagnetism, gravity, strong and weak nuclear forces. So with gravity, we will go classical and quantum, and we will do this right now for the first time that this has been done. So to Newton's cradle. With the action of the orbs in Newton's cradle, we will lift up one of the balls, say the left-hand ball, and we will drop the ball. Once the ball is released, it comes into contact with the rest of the orbs. Direct contact is achieved, and this action, Newton shows us the physical representation of kinetic energy contact and pass on with direct contact. With this, we now must recognize that direct contact between orbs is an expression between the gravitational field in direct contact with the orbs by the action of physical motion. From orb 1 through the kinetic energy reaction of, and then we will see it come through into the orb number 4, which will lift back up and then, of course, swing back through the orbs.
Right.
So from here, we can observe kinetic energy direct contact. Being in a viewpoint of both classical and quantum mechanics, an action of direct contact of kinetic energy passing is physically present. So, of course, we're still being in the classical sense of gravity, that we can see its actions. So with this, there being no transformation of kinetic energy, and I'll give an example of this, Rick. A stick of dynamite, when it explodes, transforms aspects of the physical dynamite to be expressed as kinetic energy. So, with this view, we have two views of kinetic energy, one during an action and the other by direct contact in Newton's cradle. So with the direct contact or specific action for transformed or transferred kinetic energy, which this again leads us back to the conservation of energy law, which states that the total amount of energy in a system remains constant. Energy can be transferred or transformed into kinetic energy, but the total amount of energy in the system remains fixed. So with that, we will have a view of the two: direct contact or specific action for transforming or transferred kinetic energy. So Newton's cradle is actually the middleman expression of kinetic energy. We have direct contact from the gravitational field to the direct contact of the orbs in Newton's cradle, and from there, then we can view a classical sense of gravity with the orbs.
This is so fascinating. I'm just to get the book in here because people are going to go, okay, where do I get this book? The book is available at Amazon. You can link on by going to our website, thisweekinamerica.us. The author is Martin Walsh. The book is Gravitational Fields and Dark Matter Explained. Martin, back to you. Please continue.
So with this, Rick, we can honestly now tie in classical gravity and quantum gravity, which of course, when we look at the current model of particle physics, this is the last piece of the puzzle to the current model. Now, of course, the current model of particle physics does allow for kinetic energy to be there, as described by Leibniz with the conservation of energy law. So we do know that kinetic energy is there. And when we look at the current model, it is the only item that is not expressed in the model. So, of course, we do know that kinetic energy is there, and we do have two very relevant examples of gravity's action. So, like I say, Rick, it has been quite overwhelming to see the final part of the current model put together in a working action. And as scientists have regard, this will start the theory of everything, which will tie our four fundamental forces together, all of our matter and energy in the universe, and of course, even the structure of space itself.
This has to have been and continues to be an exciting week for you as you're finding sort of a week of revelation, the final piece of the puzzle. And as someone, a researcher, a scientist, a thinker, this has to be an exciting time for you to get to this point here. We've got a few minutes left in the program. I want to ask you, how does your book fit in with the current action of the solar system?
So when I first started looking at this, I could see how gravity did work, and I just couldn't put a lot of fundamentals to it. So in book 2, so my book is actually book 1, which is on gravity, and book 2, which is on dark matter. So in book 2, it starts with the example of kinetic overlap. So I'll explain that. What that means is if we put force into an object and it moves in a straight line, we can put force in an object on its side and have it spinning as well. What we do see here is in space, those two actions will continue through the object unless acted upon by another force. So right here, we have our first view of kinetic overlap, which is kinetic energy can overlap kinetic energy in the same body and not hinder each other or flow into each other. So, of course, I had written for a fair while on that, and at that time, Rick, I did not know how the solar system worked. So once I'd finished writing the example, I had in the back of my head now turn that inside out. And in the moment of turning the example inside out, I saw about 98% of the solar system's action. So, of course, coming from seeing 0 or a couple of percent to 90% within 2 or 3 seconds, that took a lot to get my head around. Because having the solar system explained to you, not so much in words, but seeing the actions and knowing the actions, that was a huge revelation. That was an absolutely huge revelation. And of course, the solar system action is perfectly described with what I have said about dark matter and kinetic energy. And again, the current model of particle physics and of course the physical actions. So again, we go from classical gravity to quantum gravity, explains perfectly what we are doing in the solar system at this present time. So book 2 does add a historical link to the chain of the Earth and the universe spins around it, to the sun and we turn around the sun, to what I have written about the solar system in book 2.
It's so exciting, and the time has gone by so quickly. I've got about a minute left in the program. Any final thoughts you want to share here in the closing moments of our program?
So what I would like to say is, of course, the example of Newton's cradle is a classical view which we cannot deny that is physically happening. From there, we will move to quantum gravity, and we can follow the elementary particles in their development and how they pass the 4 fundamental forces, which gives us a view back on Newton's cradle, which of course, then the physical examples do not lie, and the current model of particle physics does not lie either. So of course, from this, Rick, we can now remove the gravitron from the current model, and we can put in place kinetic energy. And of course, physical examples do not lie, Rick, and we see what we have and we have what we see.
This has just been fascinating. If you've been listening, watching the program, you are on the cutting edge along with Martin. Martin Walsh is our guest on the program, coming to us via Skype from Australia. The book is Gravitational Fields and Dark Matter Explained. Everything you'll find at Amazon. Look for the book, look for Martin Walsh, and you can link on by going to our website, thisweekinamerica.us, and get all of that information. Martin, I thank you so much for getting up in the middle of the night in Australia to be with us on the program. I know you're excited about this. The audience is, I'm sure, as well. So I thank you for getting up, making that extra effort to explain what has happened to you, the last piece of the puzzle that you found just in the course of the last few days. Thank you so much for being with us on the program. We will stay in touch. And again, thank you for being with us.
Thank you, Rick, for letting me be a part of your program. And of course, it does honestly seem fitting that where this broadcast is first going to go out is the same place where they launched the man to the moon, which is Florida, which seemed to be fate within itself.
It's right down the street from where our studios are located here. So there is something interesting. Fate, I think, is where, as we were talking about this and setting up for the program. Martin Walsh, our guest on the program, the book Gravitational Fields and Dark Matter Explained. You'll find it at Amazon. Martin, once again, thank you for being with us. Thanks for listening, everybody. You'll find all of the information online at our website, thisweekinamerica.us.
This Week in America is online. You can visit our website, thisweekinamerica.us. Scott Pinkerton, associate producer of This Week in America. Jay Anderson, segment producer. Ben Watson, webmaster. Otto Bechet, director of engineering and TV production. This Week in America produced and is a trademark of Blue Funk Broadcasting, LLC. For information on all of our guests and to listen to this week's show, our website again at thisweekinamerica.us. And I'm Sean Bratton, executive producer of This Week in America.